deliver the next speech on an interesting topic, industrial internet, let me invite Mr. Pradeep Desai, technology leader, software sciences and analytics, GE Global Research. Mr. Pradeep Desai has over 2 decades of experience. He has worked in many global multinational companies like TCS, Philips Electronics, Wipro, and Tata Elxsi. He has worked on different business solutions for energy, aviation, transportation, healthcare, consumer electronics, and capital. Ladies and gentlemen, let's welcome him with a big round of applause to hear about industrial internet.
Actually, if you could just switch off the spotlight, and this lighting is good for me because I can see people. First of all, thank you very much. Okay, I'll just come. Okay, good afternoon to everybody. For me, it's been a great learning, listening to all the speakers. Secondly, I'm very happy that I've been invited to an event like this. I thank ICT, ACT, and what I'm trying to do today is to give you a feel of what's this industrial internet all about. Before I start off on that, I come from GE, General Electric. General Electric works in the following spaces. Okay. Power and water, energy management, oil and gas, GE Capital, healthcare, aviation, transportation, home and business solutions. If you look at the portfolio of the kind of work that we do in GE, it kind of touches the whole industrial gamut of business, right? And therefore, we within the company thought of coining this word called industrial internet, right? It is kind of equivalent of your Internet of Things, but since we kind of touch on the data which is of industrial nature, we said we should kind of call it industrial internet, right? Now, when you look at the data that comes from social media or retail, it's pretty different from the kind of data that we handle in the industrial space, right? These are all machine data coming from equipments, and it's also, the idea is to kind of see how do you handle this data. Now, this terminology called industrial internet is not really trademarked by GE, but we use it like a kind of a form to explain to people what is GE moving into, right? The buzzword in the company is to actually move from what we call a big iron company. So GE is known for creating all these sophisticated aviation engines, healthcare equipments, energy turbines, gas turbines, steam turbine, nuclear reactors, all of that. And we said, look, if we have to do something here, moving away and making a transformation in the company, and we kind of follow the trend in technology in a way that it's getting a little bit soft, right? If you look at the way the paradigm shift is going to happen is from machinery to, we call it the industrial revolution to the internet revolution, and going forward to what we call it the industrial internet revolution, right? So there is clearly a trend that you see that from equipment to adding value to the equipment, and how do you do that? And that's the whole story that I want to kind of talk today. So what is industrial internet, right? There are 3 pieces into the industrial internet. One is, how do you make machines intelligent, right? How do you make machines talk to machines, machines talk to humans, machine talks to the network, machine talk to anybody, right? So you started to see this, but today's machines are not there at all. In fact, it does a very bad examples of what we're talking about. So our aim is to kind of make machines intelligent. And how do you make machines intelligent? To make machines intelligent, there should be a method of collecting or feeling what's happening to it. It's almost like what's happening to you, what's happening to your body. Are you going to fall sick 3 days from now? So how do you know that? So obviously you need to have a method of capturing data from these machines. Now to capture data from the machine, that's the first thing. Now to capture data from the machine, you need to kind of collect data. You need to have a mechanism to collect the data, and therefore we use a whole lot of sensors. So there's a huge technology happening in the space of sensors and all kind of sensors, right? Mechanical, optical, ultrasound, you name it. So we have started to kind of what we call as kind of impregnate sensors into machines with a way to collect those data. So in the future, right, when an aircraft, when RNG, by the way, 80% of aviation engines are from GE. So if in the future we believe that every time an aircraft takes off, we would know what is its state. And that's what we're trying to do. So for that, we have a mechanism to collect the data, do some kind of analytics on top of it, and that's why we need what we call as advanced analytics. So all of those guys who are here, from the engineering side, mechanical side, this is an area that's going to boom. And all of you should be very happy to know that you're at that point of inflection where this is going to really kick off in the next 10 years. So making machines intelligent, having advanced analytics, right? All of that you learned in artificial intelligence, machine learning, advanced statistics, right? All of that makes a lot of sense in today's world. Way back, when I did my PhD, I worked on image processing using artificial neural nets, but it was very theoretical. Today, all of this is actually getting operational. In fact, some of your washing machines are very intelligent. It kind of understands the texture of your cloth and actually knows how to wash your clothing, right? So it's getting there. The third piece, of course, is very, very important because in the end, it's all for people. So we are in a business, and we are very proud to claim that, we are in a business that matters to humankind. We are in a business of not just doing, shifting, putting your photographs on a social media network, but you're actually making a lot of impact to society. Be it healthcare, be it creating energy, which is very, very energy efficient, be it creating aircraft engines, which is again very energy efficient, whole lot of stuff, right? So we need to understand the behavior of people in the future if we have to get this whole thing right. And we do see a pattern of how people today work, how people today kind of change to certain conditions, and we're learning all of that. And putting all of these three things together in a very hyper-connected way is what we call the industrial internet. So in a nutshell, that is what is industrial internet. Now, so that's like a 30,000 feet, philosophical statement saying what is an industrial internet. Underlying that, really, what does it mean? How do you actually do this? How do you do this industrial internet vision? And very, very clearly, there are a couple of things that quickly you need to do. One is, you just latch onto the technology advancement. You're not going to do all of this as one company. So there is a lot of advancement happening in cloud computing. And the reason we want to go to cloud is because some of these solutions are just not affordable. So all the capital investment people are talking about, is there a way to put this solution on the cloud so you can actually do a whole lot of efficient and cost valued solution, right? So I think when you look at these topics or these parameters, this is a good insight for a lot of institutions to actually start developing these kind of subject matter in your institution. That's another thing that I want to bring to the table is when you look at these things, maybe you should have a subject on this. The other thing is mobility, right? How do you so people are expecting today, to do anything, anywhere, at any time. So that's almost like, Krishna being everywhere in the Mahabharata epic, right? So that's exactly what we're trying to do in a very, very, today in a very inefficient way. But that's the point is understand what mobility technology means. Security becomes extremely important because, as is the case, there are always bad people in the universe, right? I don't know if you heard of stories where somebody hacked into a turbine and actually created a devastating effect on the turbine, right? Just as when people hack into your computers, there are people who are working, especially, we would call them the bad people, working towards hacking into turbines. Imagine hacking into a nuclear reactor and changing the parameters. And that's very devastating. So security becomes an extremely important, in the context of industrial internet. And of course, the other pieces are big data, because your ability to handle data, humanly impossible. The brain just cannot comprehend a kind of data that comes in today, right? You're talking about many, many gigabytes of data coming per second. The brain can do a fabulous work in terms of interpretation of patterns, but it just can't do anything on the computational side. So you would better leverage the technology, and how do you therefore manage the big data? So what we're talking today is actually something that humans can't do, given the understanding of the brain and the capacity for us to use the brain. I believe it's very powerful, but given what we are today, it just can't handle this kind of large data sets, right? So the whole chaos theory of looking at data at a holistic way of huge size is something that really there's no chaos in the universe. There's a pattern. But what happens is you're looking at data in time slices, so you really can't predict the next future. But if you can look at data at a very, very expanded view, you would actually see patterns repeating. But since you're taking very slices of the data set, because today's science is talking about, if you talk about statistics today, the whole statistics is based on sampling theory. Communication is sampling theory. And then you start to interpolate. The minute you start interpolating, you get into trouble. Because the interpolation is going to be very linear, and the world is not linear. And that's why, when you go to the stock market, people wonder, hey, I just can't predict this. I just can't understand the randomness. It's just that you can't comprehend the size of the data. So that big data is a very important subject, right? And then specifically in our context, like I said, we need to make our machines brilliant, and we need to create a good user experience. User experience is very important, because one of the reasons a whole lot of people say, why does companies like Apple do well, is because they cracked the way people work with equipments. I know for sure, I was in another company when the the iPod came in. We actually had that product 3 years before Apple actually introduced it, but we had a terrible interface. And therefore, usability is extremely important topic. So, in a nutshell, these kind of criteria or the parameters are very important in the context of industrial internet. Now, when you talk about why do we do this, right? I mean, end of the day, all companies are out there to make money. It's not like we are in charity business. So it's extremely important for GE-like company because we want to address two major problems of our customer, and that is basically asset optimization and operations optimization. It's actually multiples of $1 billion business for us, right? If I tell you today that we have contractual agreement with aviation industry or aviation airline companies worth $114 billion. It's a contractual agreement we have saying that we will support their aircraft for the next 10 years, for which they have already signed off $114 billion. Are we very happy with it? Yeah, because we have a signed contract. Are we sure we're going to go make money out of it? No, because we really don't know, how this aircraft will behave. An aircraft flying on a Middle East terrain is very different from aircraft flying in a tropical area, very different from aircraft flying in, let's say, North America. So the whole analytics, the ability to collect that data and analytics, it becomes extremely important. And the impact that the aircraft engine, for example, I'm just using aircraft engine, I could use any other examples. It could be healthcare, could be transportation, which is our rail business. But I just take the aircraft engine because it's the most quoted examples. So our ability to understand the behavior, the health of our engines is extremely important, and that's why airline industries actually pay us billions of dollars. So that's all about asset optimization. Operations optimization is again all about how do you, efficiently run your operations. Why do you have in your work process or a workflow, 5 steps? Can we kind of reduce it to 3 steps? So one thing that the company is very finicky is about security, so I just can't give my laptop to anybody. So anyway, so I was talking about operations, and a whole lot of things listed out there is how do you make the operations more efficient, right? Now I'll tell you, for a GE-like company or any company which is in the industrial space, why this is so important. The data shows that in the next 15 years, a 1%, we call it the power of 1, if you can improve efficiency by 1% in the freight utilization of rail, they're actually talking about a $32 billion, business, right? So very, very quickly, I just have to do a 1% improvement. It's not like I have to do a lot, but it's still very complicated. Similarly, if I have to do a predictive maintenance, run my predictive maintenance for healthcare in a better way, then I can actually have about $62 billion of business. Now, these are data that we have actually worked out. And again, for power, if somebody can say, how would the grid behave? Right? Can I predict when should I time out the way energy is going to the various, source consumption points? Because actually a lot of energy gets wasted. So if I can just manage to optimize that in a certain way, then I'm talking about a $66 billion industry, right? So, and we're talking about 1%. It's not like a very high number. So that's why it becomes extremely compelling for us in GE to really work on this topic, right? Having said that, that's what I have, and I'll just run one video. Can you run the video for me? Of what really industrial internet means in the nutshell.
There's a whole new internet at work. Machines communicating with machines, sharing a wealth of data seamlessly, tirelessly, behind the scenes. Forget real time. This is between time. Machines moving industry forward at lightning speeds. Welcome to the industrial internet. Out at sea, a large cargo ship traverses the giant waves, carrying parts destined for a far-off wind farm. Tiny sensors throughout the engine ensure everything is working properly. They report back on propeller performance and power output. Other sensors above deck monitor the ship's precious cargo and confirm its condition and safety. The ship's tracking data determines the destination and arrival time. Everything checks out. The cargo is now traveling securely aboard a hybrid evolution powered freight train. Inside the cabin, the engineer calls up a status report on the entire train. Real-time slows. Between time, a vast universe of data is collected and interpreted. In the blink of an eye, sensors calculate engine temperature, fuel efficiency, speed, weight, and vibration patterns. At the same time, sensors in the track relay the train's location to the network, where information from all other trains comes in. This gives the network the ability to coordinate movement and optimize efficiencies throughout the entire system. And our train remains on schedule. Meanwhile, at a nearby wind farm, a new turbine powers up for the very first time. Within seconds, tens of thousands of data points are analyzed, and the farm controller delivers operating instructions to the turbine, bringing it up to speed with the rest of the farm. Leveraging thousands of hours of stored data, the farm automatically calculates how to increase and decrease individual turbine output. The turbine can tailor the pitch of its blades to capture just the right amount of wind. As the farm responds to the demands of the power grid, it delivers energy as instructed. Next, the grid carries precise amounts of energy to a network of local charging stations. Drivers can charge up and head home. This is the industrial internet. Brilliant machines providing the insights to make better decisions.
Great. I request Dr. Pokumaran, Principal, NGP Institute of Technology, to honor the guest speaker. With a big round of applause, please.